Well, hello there, fellow flight simmers and cockpit builders. Now, this video here is not going to be one of my back to basic videos. This one is actually a little bit complicated, I would say. Actually, it's probably the most complicated panel that I have ever built. I got inspired after I started making the videos of 7-segment displays. I kind of got inspired to make a realistic MCP panel. So this is what this video is going to cover. I'm going to basically go over all the steps that I went through. I'm not going to show you everything, all the way through, like step by step doing it, but I'm going to show you my progress as I was going through the process. If you guys remember from my previous videos, a lot of times or in the intro or outro, I show my setup that I have, right? So when I made this MCP panel a long time ago, I kind of didn't want to make a real full-blown panel because I was just getting started, so I still didn't have all the knowledge about LEDs and 7-segment displays and everything. So I basically just did this, which is a pretty rudimentary. I mean, it still feels the need for changing all the parameters of the MCP, but it doesn't have the whole look and everything like a real one. So that's why I decided that maybe now it's time to start building a realistic looking one with almost all the buttons and switches and everything that they have. So here's what I started with. As you can tell, I was already playing around with 7-segment displays, so that was what caused me to start working on this. So I decided to get a piece of wood and laying out the measurements and everything of what I would need for the 7-segment displays and for the buttons and encoders and everything. So that's what I came up with. And then I was playing around a little bit with with these things. As you remember, on one of my videos I mentioned that at the time I only had the 4-digit 7-segment displays. I had the 2 dots for the clock. They didn't have the dots after each digit, and I couldn't get these to work. So that's what I had, but at least they were the same size, so I was able to work with that. So then I went ahead and cut all my holes, and this is where having a CNC machine would have really came in handy, because I did it with a drill and then with a little jigsaw, and it was easy, but it wasn't that easy, and obviously you can see that the lines are not very straight or whatever, but I figured that when it's all said and done, a lot of it's going to be covered up by the components, so it doesn't really matter, right? So then I painted it. I started putting some of the components that I did have. I had already ordered the 6-digit ones here, so I put them on. I put a lot of these Corey type switches that I already had, and then the encoders, which also I already had, I believe. I think I did have to order some more because I didn't have enough, but I had most of them. All right, and then I actually went ahead and bought myself a label maker too, because as you guys have probably seen in my previous ones, a lot of the times when I made something, I would do it with a white paint marker or something, which I still did on this one a little bit, but I tried to do the majority of it with a label maker now. So obviously it looks a lot better this way, right? For the vertical speed wheel, I had to kind of figure out how I was going to do that. So I looked online for a bunch of different circles or materials, that I think would give me what I need. But so I ended up buying these little wooden circles here, and what I ended up doing was gluing 2 of them together so that they can be a little bit thicker. And then I cut the hole and everything to put it on the encoder, and then went about it that way. So once I put it on, it looked like this. And man, one of the things that I really had a hard time with was how wide to make this hole, because no matter how much I tried to make the wheel be as straight as possible, it seems like it always would jiggle side to side a little bit. And I put hot glue on it too, so you can see right here I put some hot glue on it in the back on both sides actually. And I put this little piece of wood. I glued and screwed the encoder onto it so that it can be laying sideways like this. And this is how it looks from another angle. So you can see that I put hot glue on both sides of it like this. And that's what ended up working out. So at this point, I was still missing some of my 4-digit 7-segment displays. So I just kind of had to wait for parts. Oh, and I also was missing a few of the Corey type switch buttons as well. So I had to wait for that to come in. So right here, I pretty much already had everything in there except for the autopilot disconnect switch right here. But I already had all the labels and everything, so I was getting ready to start my wiring. And remember, if you're going to use 7-segment displays with an output multiplexer, you need to have a resistor between the clock signal and ground. So as you can see here, I already put a resistor on each one of my displays right here. And this is pretty much what it looked like once I installed everything except for that autopilot disconnect switch, like I told you right here, the disengage switch. So it's already looking pretty busy. And you know, a lot of times I know people have asked me before, and I had made a video about Corey type switches, but I think I'm gonna have to also redo that one as an updated one. Even though these switches have a lot of terminals, we're not gonna use all of them. You know, the two middle ones right here are for the LED, and then the three top ones and the three bottom ones are for the switch. So you can actually have either a normally open function to this switch and a normally closed one, because the middle one and one of these is normally closed, and the middle one with one of these is normally open. So but we're only going to be using two on the top and the two in the middle. So you know, even though they look a little daunting and confusing, it's not that bad if you just take it step at a time. And that's one of the things that I want to say about building something like this. You know, when you look at the finished product, yes, it looks very complicated, it looks very scary, but you know, when you think about it and take it one step at a time, which is what I'm trying to do with this video, as I'm going to be showing you the process of wiring it, it's not that bad. You know, you just have to make sure that you keep all your wiring in order, that you put them in the right place, and then when it comes time to assign them, you have to make sure you assign them to the right pins, or else nothing is going to match, right? So I think this is a part where I started my wiring, and from here on I actually recorded little clips of video after each section of wiring and explained what I did. So let's go on to the wiring part. Okay, so at this point I was already done with putting all the components onto my MCP panel here. So the first thing I did was daisy chain the ground to all the different components that are going to use the ground. And what I'm doing now here is I have this little multimeter here again, and I'm going to make sure that I got continuity all the way through before I decide to solder everything, you know, in case I miss something. So this is going to be the main ground right here that's going to go through everything. So I could just test. I tested every one of them already, but just so you can see, I can go throughout the whole thing to make sure that everything has ground. And right now it's not even soldered, so. But as you can see, everything is good. So now I can go ahead and wire it. The only thing that I wanted to mention right now, and I will mention it again when that time comes, is that the middle pins right here on all the Corey type switches, those are for the LEDs, the two middle ones right here. So you notice that I didn't put any ground on those because if you remember correctly, the 5 volts are going to go to one of the pins, and the ground is actually going to go to the DM13A on each of the LEDs. So that's why I did not daisy chain the ground to those pins right there. Okay, so I'm back once again, and as you can see now, I have wired up all the 5-volt rail lines to all the displays and all the LEDs that are on the Corey type switches as well, and also the 3 LEDs for the 2 flight directors here and here, and also for the auto throttle armed LED that's up here. So I just basically, I'm going to get everything off of this one lead here that's going to come from the 5 volts from the separate power supply, and then like I did before, I can just test to make sure that I'm getting power throughout the whole thing. And let me see all the way back here. So yep, everything looks good. And I like to do this every time, you know, before I go ahead and solder everything, because I don't want to do all the work and then find out that I missed something. So this is a good way. And like I said, off camera, I did test, you know, the actual connection to every single component, not just to the outer ones. Okay, so after we got all the ground wires done and the 5-volt wiring also, I decided the next step would be related to the 7-segment displays. So if we go over to the website, you can see here I have TM1637, so we're looking at this bottom one here. So the next thing I decided to do was do the DIN, I guess is data in. So that one would go to pin 29 on the Arduino or on my distribution hub, which is the T line. And he's using a brown wire here. So I decided to also use a brown wire, which after the fact, I decided maybe that was a bad idea because it looks very similar to the red wire. Remember, once again, the T line is going to be shared between all the displays. So I can basically just daisy chain that one as well. So what I did here is I started here on the edge. I took this brown wire, I linked up to the second one and continued to the third one and so on all the way until the last one. And then I just got this one here that's going to come out here. And this is the one that's going to go to the distribution hub on the T line. Alright, so next up I decided to continue the wiring that was left for the TM1637 7-segment displays, and that's what I did next. So if we go back over to the website, and you can see that the clock signal is going to be going to the pin on the output multiplexer where that screen is going to be connected. And that one, of course, is going to be one individual wire per display. So if we go back to my overhead view here, you can see that I have 6 wires right here, one of them coming from each of the 1637 displays. Okay, as I got closer to thinking about how I was going to do all these connections here, I decided to try to lay out my intentions, for connecting everything. So as you can see right here, I got all the wires for those displays that are coming right here. So my intention is this. This one right here is going to be the output multiplexer where all the clock signals from all the displays are going to be. And also I'm going to branch off of this one to connect the DM13A for all the LEDs. So speaking of the LEDs, my plan right now is that all the LEDs that are on this half of the display are going to come over to this side. And then the ones over here on this half of the MCP are going to come over to this side. And then all the buttons and switches that are on this half are going to go to this input multiplexer. And then once again, all the buttons and switches on this half and encoders are going to come to this input multiplexer. The only thing that I'm realizing right now is that I needed one more pin for one of the switches. So I think I'm going to end up taking this middle one right here. I'm going to end up taking that one over directly to the Arduino, since I'm not willing to put another multiplexer just for one switch, at least not for now. And this right here is going to be my distribution hub, my data bus, my power and ground distribution hub. So I'm going to connect the input multiplexers, the output multiplexer over to this, and then this is going to go to the main data distribution hub that goes to the Arduino. Alright, so the next thing I decided to do was connect the negatives of the LEDs that are embedded in the Cori type switches here. So I decided to use white for all of those. And also the LEDs of the flight directors and the auto throttle armed, I also connected those. So the only thing I did not have room for was the last one over here. That was for the flight director on the co-pilot side. I would need one more pin for that. So what I decided to do for that one was just use it with a switch. So basically when I turn on the switch, it's going to turn on that LED. But that one is also getting its power from the 5-volt rail that everything else is going to get its power from. And as you can see right here, I already put DM13A right there and connected all the leads to it. I did not solder them to the DM13A. I just put little headers on it, male headers, and connected them in there. This is a pretty secure connection method, so I feel comfortable that that's not going to come loose or anything. Even when you try to remove them, it's pretty good. So you can see that it's starting to take shape. So obviously I'm going to have to put these wires laying over the middle of the other MUX that's going to be right here. These right here, I'm pretty sure I could just push them out of the way right there. But and then this one right here will also go laying through the middle here. And like I said before, the distribution hub is going to end up being right here. So all right, I'll be back with more when I make more progress. Okay, after what seems like a lot of hours of cutting, crimping, soldering, and heat shrinking wires, finally done with all the buttons that are on this panel here. So as you can see, I got all the yellow wires up on the 2 multiplexers like I had mentioned before. And so everything is already connected. The only thing, like I think I told you guys earlier, there was going to be one button that didn't have space here on the multiplexers. So what I'm going to end up doing is just putting a wire connected to this one here that you can barely see, and then that one's going to go directly to the Arduino instead of putting another multiplexer for just one wire. So I got multiplexer, I'm going to call it multiplexer 1 over here, which I'm going to be connecting to Arduino pin number 11. Then I got multiplexer number 2 here, which is going to be connected to Arduino pin number 12. And then right here is going to be the output multiplexer, which will be on pin number 13. So as you can see right now, I do still have to do the wiring for the rest of the DM13A. And then I also still have to connect the displays to the output multiplexer, and then I have to put all the wires that are gonna go to the hub for the data lines and the address lines. So I'll be back again with another little update. One thing I did want to mention real quick is, obviously when you're doing this, when you're connecting a ton of wires to different multiplexers or even directly to the Arduino, you do have to make sure that you are connecting the right button or switch or encoder to the right pin numbers that you intend to use, because otherwise when you go to assign the parameters, if you don't have things connected in the right place, obviously they're not going to work. You're going to make something else function that you're not intending to. So that is one of the very, very important things to keep in mind, is make sure you either write them down or do something to make sure that you're connecting everything to the actual pins where you intend to assign them to. Alright, so the next thing I did now, I pretty much connected the clock signal from all the TM1637 7-segment displays, and I put them on the output multiplexer right here. And I ran out of that heat shrink wrapping for the size that I needed right here, so I can do that later, but right now I just did one and skipped one, and so I used 0, 2, 4, 6, 8, and 10 for the displays. That way there's one empty one between each one so they don't touch. And then I put the DM13A on number 15 on the output multiplexer right here. So as you can see, I also got the D line and the L line from the DM13A, and I brought it over to the distribution hub, which is going to be where they spread out to go towards the Arduino out on this side over here. So I just put myself a little little markings right here so that I can remember, even though I have them color coded, but just so I can remember which one is which a little bit easier. Another thing I did was I put the voltage, the 5-volt line and the ground line that spread out throughout the entire system to everything that requires 5 volts or everything that requires ground, which is everything. And then I put them here on the distribution hub as well. So remember, these 5 volts, I'm going to actually get them off of a separate power supply. I'm not going to get them off of the Arduino, because they're going to power all the LEDs and they're going to power the displays. So you cannot get them from the Arduino when you have that many things. Alright, so the only thing I'm going to do now is I think I'm going to daisy chain the S0 through S3 that goes through all the multiplexers. I'm going to daisy chain them and go to the distribution hub as well. And then I'm going to do the ground and the power that's going to go to each one of the multiplexers as well, and to the DM13A. Okay, so I'm finally to the point where I finished all the wiring except for the parts that are going to go to the Arduino. So for example, you can see on my multiplexers there that I have on the input multiplexers the signal pin way at the end over here. It doesn't have anything in it yet because that's going to go directly to the Arduino. And then on this one it's going to be the green pin right here. I think you're able to see that right there. So those are going to go directly to the Arduino. And of course, on the distribution hub, that's going to go directly closer to the distribution hub that I have attached to the Arduino right now. So if we go over to the website over here on this page where it talks about input multiplexers, I pretty much did the same thing. You can see that, this is going to be branching the S0 through S3 lines, the address lines. It's just basically daisy chaining from one to the other, and then to the, in this case, it's going directly to the Arduino, but in my case, it's going to my distribution hub. So you can see that I did the same thing. I pretty much took, this is the orange, white, yellow, and green, and I took them from one multiplexer to the other multiplexer to the other multiplexer, and then to the distribution hub where they all end up. Now, I did the same thing with the power lines, but on this one, I took advantage of the fact that the ground line and the EN pin on the input multiplexers are daisy chained together with a little piece of wire on the bottom. So basically I took this ground going to this ground, and then from the EN pin I went to a ground over here. Oh, you can't see it, it's just off the screen, but it's on one of the switches. So, and then same thing over here, I went from the ground of the DM13A to the ground to the EN pin on this multiplexer, and then from the ground pin of the multiplexer I went to the main ground on the distribution hub. Now if we go over to the web page again and we go over to the output multiplexer area, you can see right here that on the output multiplexers, the EN pin is the one that goes directly to the Arduino, and the signal line does get used. Unlike the input multiplexer, which the signal line goes to the Arduino pin and the EN line is just jumped over the ground. And I'm not going to go, deep into this. If you need to review all this stuff about multiplexers, I'm going to tell you to go watch my video that deals specifically with multiplexers. This is just a quick overview of how I did my wiring right here. So going back to the overhead view here, you can see that I took the signal pin over here on the output multiplexer. It's a blue wire here, and I took it all the way over here to the distribution hub, and that's where it lands. And then, like I said before, the EN pin is going to be the one that takes the wire to the Arduino on the pin that I have assigned the output multiplexer on. Alright, so I guess the next part that I'm going to do when I come back is going to be actually connecting it to the Arduino, and then we're going to do the configuration of everything, and then we're going to see if everything works. Okay, I think I'm finally to the point where I have connected everything, and we are ready to start making configurations and then testing everything out, and hopefully I didn't miss anything too crucial or important where it would basically make the whole system unusable or unfunctionable. Is that a word? I don't know. Anyway, so what I did right now on since the last time, basically I took the wires from the signal pin of the input multiplexers and took them over to the Arduino to pin number 11 and 12 for this one here. And then on the output multiplexer, I took the EN pin on the multiplexer and put it on pin number 13, which is where the output multiplexer is going to go. Alright, so another thing I did is I connected the power supply over here that is going to be supplying the 5 volts to all the chips on the multiplexers, on the DM13A, on the displays, and all of the LEDs. I'm only using this brick right here for now. It's a 5.3 volt 500 milliamp power supply, but it should be enough to supply power to all of the components on this build. So one more thing I did is, you can see over here that I connected all the wires from the distribution hub over to the other distribution hub. I mean, I could have easily just, since right here I am close enough, I could have easily just taken all the wires right here basically and took them directly to this distribution hub here. But I wanted to do it in a way to demonstrate, like, for example, if you had this MCP panel far away from where you had your Arduino Mega and your main distribution hub, that you can take wires over to that and basically expand your distribution hub. Then if I have other instruments or other multiplexers or anything around here in this general area, I can also branch off of here to provide all the data lines and the address lines to those. So one more thing, you notice that I put the 5 volts in the ground for the power supply over here on the bottom right corner here. But I also took a ground over to the main ground that's going to eventually end up on the Arduino, because I don't know if you remember, somewhere along all my other videos, it is very important that whatever power supplies you connect that are going to be part of the system, the ground has to join with a common system ground, or then it won't work. So that's very important as well. So I guess we can go ahead and start doing the configuration and see if everything works out when we're done with it.